Hello. So today I'm going to be making some crystal radio kits for Cub Scouts to be able to make crystal radios as a part of their bear electives. And so first I'm just going to kind of walk through some of the pieces that are involved. There's two that you kind of have to plan ahead for because they're a little bit tougher to come by. The first is kind of the heart of the crystal radio, which are going to be a germanium diode. Um, I've heard that pretty much any signaling radio, signaling diode will work, but these are a pretty popular one for building the crystal radios. I was able to find them online without too much trouble at all. And a pack of 10 here, which is great for one den of Cub Scouts. Um, I've heard that you want to make sure that you avoid a power diode and you stick with the signaling diode. And the germanium ones apparently are the best for making these little crystal radios. The second part that might take a little bit of time to acquire is this piezoelectric earphone. You can't use the typical headphones that come on your iPhone or you just find at Walmart for using on a portable radio. These are much more sensitive, and the radio is not going to work very well if you don't have the correct type of earphone. So I'll make sure to include where to find these to order them online. A couple other miscellaneous things. One is I'm going to use a length of PVC here. It's 3/4 inch PVC. I'm going to cut that into sections to make a frame for a coil. What's going to go on the coil is some magnet wire. Here I have 21 AUG magnet wire, 21 gauge. It's 50 feet long. I use 25 feet for each radio. What this is a piece of copper wire, and on the outside it has an enamel coating so that it can be coiled together and the coils won't conduct electricity through the coil. The electricity will have to go all the way around the coil to get from one side to the other. I've found this at Fry's locally here in Houston. As well as many of the other parts. I did not find the earphones and the diodes at Fry's. I had to find those online, but everything else I was able to find at a electronics retailer. Next, I have some test leads or clips, and basically these are just clamps that will allow us to attach our ground cord to a metal pipe or some other good source of ground. It could be any type of alligator clip, something preferably that opens up a little bit wider so that it could go on, say, a hose bib on the side of a house or a cold water pipe under a sink. But these weren't priced terribly bad, and I think they'll be pretty effective. I'm going to use two types of wire. One is I found these 100-foot spools of 26 gauge solid copper wire. I'm going to use this solid copper wire to make the antenna as well as the, these are just going to actually make the antenna. And I'm actually going to use this stranded wire for the ground cable. It's not too terribly important exactly what gauge of wire you use. The stranded wire is less expensive than the solid. It's one thing to keep in mind. Okay. One other piece that's going to make this a lot easier to assemble for the Cub Scouts is I got these terminal connectors, and so before we start assembling, I'll have all of the components with terminals on the end, and so we'll be able to screw these terminals to our mounting block so that the Cub Scouts aren't having to worry about twisting wires or soldering or anything else that might be a little bit of a challenge within a single den meeting. And then as a frame, I've cut a piece of pine board and basically 5.5 by 5.5 squares. And on this piece of pine board, we're going to mount all of the components. As far as tools are concerned, you're going to need a saw to cut the PVC. You're going to need a drill with a couple of different drill bits. I've got this relatively small bit for drilling pilot holes, and then I have a larger bit that I'm going to use as well on the PVC so that the screwdriver can fit through one half of the PVC when attaching it to the board. You'll see how that works a little bit later. Wire stripper and wire cutter, as well as a crimper for the terminal connectors. Of course, a screwdriver. Some screws. I'm using these 6 by 3/4 inch wood screws. And some good old plain old clear tape, transparent tape. And then we'll get started. So the first part of assembling the kit is to make this 4-inch piece of PVC, 3/4 inch PVC, which is going to be the frame for wrapping our magnet wire around to make the coil for the radio so that we can tune the radio. So what I have done is I started with the piece of PVC and I drilled straight through with this pilot bit to create the hole so that I can attach it to this piece of board. After going all the way through with the pilot bit, on each end I use this larger bit to open it up so that I'll be able to fit the screwdriver through. So the screwdriver can go through the larger hole, and then on the opposite end we have the smaller pilot hole for the screw that'll allow us to attach it straight to our board. And so now that I have the pilot holes drilled in my piece of PVC, what I want to go ahead and do is transfer those holes into our board. So I'll just locate the hole using the PVC as a template, make a little mark in the board on each end. So now that I have the 2 holes located, I can use my drill to go ahead and get the pilot holes in the board so that now when I have my coil ready, I'll be able to attach that to the board without any difficulty. Okay, I'm ready to go ahead and make a coil. And so what I'm going to do is I'm going to start with just unspooling a little bit of the magnet wire here. And I'm going to leave several inches, about 3 to 4 inches, probably just 3 will be fine, off the end. And I'm going to start just inside. It's probably difficult to see, but the pilot hole is right here on the end. I'm going to start the magnet wire just inside that pilot hole and then get a piece of tape. The tape's just going to help hold the wire in place while we wrap it. And so I'm going to push this tape down. I'm going to wrap around the edge, make sure my wire is still lined up where I'd like it to start. Good deal. Right there. Okay. Now I'm just going to start, well, actually what I'm going to do is I'm going to tuck the end of this wire inside the PVC to kind of keep it out of my way while I'm wrapping. And then I'm going to just start wrapping the PVC with the wire. You're going to have to keep some tension on the wire while you're wrapping. If you don't, it'll coil on you and you'll have to kind of fix it. It won't be very pleasant. So just keep a little bit of tension. And so what I'm doing is I'm pressing down with my thumb, and at the same time I'm twisting the PVC. And by pushing down with my thumb, the wire has pretty much no choice but to follow exactly beside the wire that's already down, and you can see that we're making a coil. And so I'll start going a little bit faster. So you start getting a gap, just push it up. And then this will take a couple minutes. I'm not going to record the whole thing here. You can kind of see, and then we'll pick back up when I'm near the end. I will comment that this spool is 50 feet of 21 gauge, and I found that that spool is perfect to make 2 of these coils. So I'm going to wrap about 25 feet. I actually don't have to measure. I started with a 4-inch piece of PVC, made my 2 holes, and I know that as long as I stop when I get about right here, it's going to be just almost exactly 25 feet of coil of wire, and I'll have just enough to make the next coil. So I'm going to continue this, and I'll see you in just a second. Okay, I'm just about done wrapping here. You can see my coil, which I started over here at this pilot hole, is almost at the end at the other pilot hole, and it's just about right here lined up at my screwdriver slot. You can see there's a couple of little tiny gaps here between some of my wires, and that's not going to be a problem. You know, you want to try to keep it as tight of a coil as possible here, but you know, you don't have to be absolutely perfect to be able to pick up some AM radio stations with this. So now that I've gotten all the way over here to my other hole, what I'm going to do is I'm going to hold it down with my thumb. I'm just going to go ahead and bend the wire around so it points back out the other direction. And so what that's going to end up with is my coil is going to have wires pointing off of both sides here. And so now that I have my coil with wire going off each direction, I'll use my wire cutter, and I'll leave you know, a couple inches here for hookup wire. Get my coil out of the way. So there's my coil. I'm still holding this down. I'm going to use some tape so that this will not unspool on me while I situate it onto the board. So now my coil is a little bit stable. So here's the board that we drilled the pilot holes in earlier. There's my pilot holes, which are going to line up with this piece. So I'm just going to get two of my wood screws. My screwdriver. And I found the easiest way to do this is just put a screw on my screwdriver, take my coil upside down, and there we go. Go ahead and start it just a little bit so that we have enough screw poking out that we can locate that on our pilot hole. Get my other screw. Be too easy if it worked on the first time. Once again, a couple of turns so that we have enough of the screw poking out that we can locate that on our pilot hole. And then I'm going to go ahead and attach this to the board. And as far as assembly to the mounting board, this is all that I'm going to do for the Cub Scouts prior to the DIN meeting. This coil is wanting to unravel a little bit. The tape is just kind of a temporary hold on there, and if we try to let all the Cub Scouts do this, it's probably going to unravel on them, and we want to focus on them assembling the radio and getting to listen and tune the radio over rewrapping something that might be a little bit tough for some scouts. Some scouts might be just fine at doing this. Others might be challenged based on their fine motor skills. And so just this one part of the assembly ahead of time will just ensure that we have a smooth meeting. But you know, it's up to you how much you want your scouts to do individually versus how much you want to get ready for them ahead of time. And so basically that's the assembly I'm going to do ahead of time. So we have a coil, we have 25 feet of 21 gauge magnet wire wrapped around this piece of PVC, and that's ready to go. Now, I talked about the enamel coating on this magnet wire, and so you can see that each wrap of the coil touches the one beside it, but the electricity can't go straight through the coil. Electricity has to go all the way around each wrapping of the wire because there is a very fine enamel coating. The wire can be sanded to expose the copper underneath the enamel coating, and that'll allow you to establish your connections. And then we're actually going to sand a bit off of the top here too, so that when we want to tune the radio, the piece we're going to tune with is going to be able to make contact with the top here to choose how much of the coil is involved in the circuit. And so that's the end of getting the coil mounted onto our mounting board. For our tuner to be able to work properly, we're going to need to remove some of the enamel from the top of the coil. And what that'll allow us to do is to attach our tuning device, which is no more than a paper clip. It'll make a wiper. And so this wiper needs to be able to sit on top of the coil and slide back and forth to tune the radio. And for that to work, the paper clip needs to make contact with the copper, not just the enamel, but the copper of the coil. So what we're going to do is we're going to sand the top of the enamel off of the coil, and the paper clip will be able to make contact with the actual coil. Now, the obvious way to do that is with some sandpaper. So you can use sandpaper to remove the enamel off of the top of the coil. Or you can use a sanding bit on your trusty Dremel tool, which will do the same thing and a lot faster. What you want to make sure of is that you don't cause your coil to unwrap as a result of doing this. But I'll turn the Dremel tool on. And there we go. Now, if we look at the top of the coil, if I can get the light just right, oh, there we go. You can see that the copper is exposed from underneath the enamel. And so as our wiper, which is the paper clip, rubs across the top of this coil, that whatever is flowing through the wiper will start at this point in the coil and only have to travel through a certain amount of coil. So if the wiper is over here, it'll only have to flow through, about 15 wraps of coil. If it's over here, it's got what looks like closer to 100 wraps of coil. Now, on the ends of our wire here, we'll also need to go through the enamel so that we can attach our terminal connections. Once again, I can use the Dremel tool for that. However, just prior to doing that, I need to straighten out the wire, because with this little bend in it, like this piece has, it's got a little bend in the end of it, it's going to be kind of hard to work on. So I'm just going to use some needle nose pliers, straighten this out a little bit. This one could use a little bit of help too. Okay, and then once again I'm just going to use the Dremel tool. And there we go. The end of the wire is exposed. You can see that it's changed to the copper color, which is the color of the actual copper wire as opposed to the red color of the enamel coating. And I'm going to do the exact same thing on the other end as well. To attach the terminals, I found in this particular project, because the way we're going to attach, I don't have to worry about the insulation too much. I found it's actually easier to remove the plastic insulation from the terminal. And then I'm going to attach a terminal to each end of the coil using the crimping portion of my wire stripper. You can use a variety of pliers and tools to do this, but the one that's made for it is, of course, the best. So we'll crimp that on to this end. And to get it pretty tight with these small gauge wires, this is a 21 gauge wire. It takes a pretty good crimp to make sure it's on there firmly. The last thing you want to happen during assembly is have one of these slip off. And I'll make sure to bring extra terminals and the crimping tool to the DIN meeting just in case that is what happens. But if you get it tight enough, hopefully you won't have any issues during assembly by the Cub Scouts. Okay, so we have our coil, we have a terminal on each end of the coil that we can use to a screw to attach to the board. We have the top part of the coil exposed by removing the enamel so that our wiper can attach to it, and we're ready for the next step. Okay, next I'm going to get the terminals attached to each of the electrical components that are used in the radio. One of them I failed to mention earlier was you need a 47 k ohm resistor. It doesn't have to be exactly 47 k ohm. I believe the instructions that I looked at said anything between 30 and 100 would work, but I found that there was this collection here of 100 of these resistors for about $3. So it was the smallest quantity I could find it in. But I'm going to grab one of these resistors. I'm going to get one of the diodes. I have the paper clip that I have unwound so that it is a long single piece. I have a single headphone, and I have a bunch of terminals available. And so with this headphone, depending on which ones you get, they might come with a connector on the end, or it might just be bare wire. And in this case, because I'm going to use the terminals I have, I'm going to go ahead and just cut the end off there. I'm not going to need that connector at all. And so what we'll do is we'll use our wire stripper to expose the ends here. And this is tiny wire, so even my 22 gauge stripper has a little bit of trouble with it. And there we go, one end. And the other end went a little quicker. So this is stranded, so I'm just going to get the strands to thicken up a little bit, fold it in half. That'll make it nice and easy to insert into our terminals. Okay, so basically at this point I have 1, 2, 3, 4, 5, 6, 7 terminals that I'm going to attach. Everything's going to get a terminal on each end except for the paper clip. The paper clip is only going to need a terminal on one end of it. And I'll show you the reason for that in just a sec. So our paper clip will be attached here. The end will be bent so that it makes contact with the coil, and then it can slide back and forth. And so that's why we only need a terminal on one end, because the other end of the paper clip makes direct contact with the coil itself. And so once you have one end of the paperclip done, you're done with the paperclip. Then I'm just going to go ahead and put one terminal on each end of the headphones, each end of the resistor, and each end of the diode. And at that point, we'll be ready to move on to the antenna and ground wire. And after a few minutes of squishing on the crimping tool, I have the wiper paperclip with one end with the terminal, the resistor with terminals on either end, the diode with the the diode with terminals on either end, the headphone with terminals on both leads to the headphone itself. And so we have two other pieces that we need to assemble. One is the antenna and the other is the ground lead. Now for the antenna, I'm using the solid copper wire that I showed you a moment ago. It's the same as this. I got it in 100-foot spools, and I cut it in half so that each antenna is 50 feet long. And so I have a 50-foot section of plain copper wire here. And all I need to do to the antenna is take one end, strip just a tad bit off the end, and attach a terminal, and we are done assembling our antenna. There's not a whole lot to that piece other than the fact that it's a wire that we can attach to our project. Make sure this is nice and tight so I don't have to worry about it coming out later. And there we go. The antenna is complete. The next piece, which I'm going to use the stranded wire for, is the ground wire. So I'm just going to pull off approximately 10 feet here of the wire. Go ahead and cut it. And on the ground wire, I'm going to need to strip both ends. So on one end, I'm going to attach one of the terminals, which you have seen me do several times already. So I don't think that's going to be too much of a challenge. We're going to put a terminal here on one end. And on the other end, we're going to put one of our clips so that it can be attached to a place that will give us a nice ground for our crystal radio. So these clips, let's go ahead and open up the package here, take one out. The way that these that I purchased happen to attach is with a screw terminal. Depending on what type you purchase, it might be a crimp or some other attachment. The screw terminal is pretty easy to work with. And so all we need to do on this end, I'm going to put a little bend in the end of my wire. I'm going to hook it onto the screw terminal, tighten down the terminal, make sure that the wire stays underneath it all the way around. Here we go. Tighten the screw down. So now the clip can be used to attach to whatever our grounding device is, whether that be a metal pipe in the house like a cold water pipe, or it could be a copper grounding wire rod outside of the home. The important thing is not to try to attach this to any part of a plug. There is a ground wire on a home plug. However, the last thing we want to do is encourage Cub Scouts to be wiring into their home's wiring system. That would not be something that would be very safe. So the other end, as I said, just needs to have a terminal on it. So we'll have our clip on one end, terminal on the other. I'm going to go ahead and do that, and then we will be done with all of our pieces and ready to assemble. Okay, so there we have it. Grounding wire, alligator clip, terminal, headphone, antenna. Now, to assemble it, what we're going to need are some pilot holes in our board, and we actually are only going to need 3 of them because all of these various components are only going to attach in 3 different places, and then it'll be ready for a Cub Scout to assemble. Being that this board is relatively small, it's not going to be difficult to make sure that the terminals can all reach. The only one I'm going to be a little bit specific about is I want to make sure that my wiper can attach to the left end of the coil here. So my first pilot hole is just going to be marked where the left end of the coil is able to reach, kind of towards the middle of the coil. And so once I have that located, I'll just get my pilot hole ready to go. Now the second terminal I need spaced a little bit away from that so that I don't end up accidentally connecting the terminals together. So I'm just going to take the right edge of the coil here and I'm going to mark that to be where my second terminal is. Once that's marked, I'll go ahead and drill the pilot hole. Now the third terminal, I'm just going to kind of make a triangle. It needs to be positioned so that the resistor and the diode can reach it, but as you can tell, these components are relatively long, so as long as I kind of position it here as in a triangle location, we won't have any trouble with our components reaching. Alright, there we have it. We have a completely ready to go, ready to assemble crystal radio. The only thing that will need to go along with what you've seen so far are 3 screws that can be used to attach our terminals to our board. So next we'll jump into the assembly. Okay, so this is the part of assembling the crystal radio that the Cub Scouts get to have a lot of fun with. This is the part where you've done the prep work. You've got all the components that are needed, all of the pieces, have them bagged up together so that it's one kit per scout. They have all the pieces they need. Make sure you have enough screwdrivers for each of your scouts so that they're not all waiting for each other. And you get to guide them through the assembly process. And what I'm going to suggest here is to start with the easiest terminal first so they get a little bit of practice. And the easiest terminal is going to be this right end of the coil. And so all they need to do is line up the right end of the coil wire over the pilot hole, and they're going to need 2 additional pieces to attach to this position. They're going to need their antenna wire, so that needs to be lined up as well. And then they're also going to need the resistor. They're going to need the diode. Now, I know normally in electronics it's very important which way a diode faces. The way I've read this project, it actually does not matter. That it can be faced either with the little band pointing towards the coil or the band pointed away from the coil. When I did my prototype, I did it with the band facing the coil, and so that's the way I'm going to do this one as well. Although what I've read says it doesn't matter, although I haven't verified that. And so what the Scout is going to need to do is they're going to need to line up these 3 terminals all in one spot, get a screw, and push it through all 3 of the terminals. Now, if they have any trouble with it, what you might do is you might tell them, well, instead of trying to do it all on the board, push the screw through the antenna, push the screw through the end of the diode terminal, and then once you have those 2 on there, it's a lot easier to hold the screw over your pilot hole and then assemble. Now, the only thing they'll kind of want to make sure that they do is they don't have their diode pointed the complete opposite direction. Kind of want your diode pointed in the general direction of the pilot hole in the bottom here, because that's where it's going to go, and probably have your antenna wire pointed out to the side here so that it's not in the way of all these components in the center when we get there. And so just go ahead and finish screwing that down. And there we go. So we have the antenna wire, the right end of the coil, and the diode all attached to one terminal. Now the next step is going to be to just bend the diode leads and line it up over the bottom hole, because that's where the diode is going to go to. The other thing we're going to need at this terminal is we're going to need our resistor, so we can have our resistor ready to go. And we'll need one end of the headphone, and it doesn't matter which end of the headphone you select. So we'll follow the same steps here. We'll take our loose pieces, we'll put our screw through that, we'll put our through the headphone, we'll put our screw through the resistor, and then we'll line it up with the pieces that are on our board and start screwing that down. Now once again, I'm just going to kind of make sure that the resistor is pointed at the hole where it's going to. It's going to match up with that and keep this headphone wire kind of out of its way. So as I hold these down, I'm going to screw this in. And there we go. So I'll go ahead and bend the resistor. So we kind of have two pieces that are set, and everything else is going to attach to this terminal. So review again, we have a right end of the coil, goes to the antenna, goes to the diode. The diode attaches to one end of the headphone and one end of the resistor. And then everything else, which is the other end of our headphone, our wiper paper clip, our ground wire, the other end of our resistor, and the other end of our coil are all going to go into the same location. So I'll grab my last screw and I'll start stacking on the different pieces. So we have our wiper blade, we have our end of the headphone, we have our grounding wire, and then we have the two pieces that are already on our board, which are the resistor and the end of the coil. So I'll kind of mush that together. This is the more challenging one because there's so many components that are going into one terminal. And then what I'm going to do here is I'm going to kind of get my headphone pointed out of the way, my grounding rod pointed out of the way towards this direction, and make sure that my wiper is pointed towards the center of the coil. See, the wiper is pointed towards, not exact, but close enough to the center of the coil so that it'll be able to be bent to go to either direct end of the coil. So let's push all that down and screw it in. And there we go. So we have 5 components attached here, 3 components attached here, and 3 here. And what I'm going to do with my wiper blade is I'm just going to kind of bend it so that it makes contact with the coil. There's not an exact science to this, but any bend in it that allows you to have it start at one end of the coil and then you can slide it over to the other end of the coil and it continue to make contact is exactly what you need. So this is our tuning dial or tuning coil, although in a radio system what you're twisting on the radio is adjusting the capacitance of a piece, which is tuning, and in our case we're adjusting the position on a coil, which is how we're tuning our radio. We have our earpiece, which obviously is going to go to your ear. We have our antenna lead, which needs to try to get it stretched out and high up off of the ground, and then we have our grounding connector, which we need to clip to metal that goes to the ground. And so we'll head outside and try out our crystal radio and see how it works. Now here's an important part of our project. In this case I'm going to use this hose bib as an attachment for my ground, and all of the metal plumbing in the home is wired into a ground so that if there's a lightning strike, that energy that goes through the metal and the plumbing is directed into the ground as opposed to causing other problems. And so what we're going to do is we're going to just take our grounding clip, attach it to the bare metal here on the the plumbing. Now that our clip is attached, we have our radio grounded. And so next we're going to turn to the antenna. Well, here in my backyard, the choice of tall things is kind of limited. So what I've done is I've actually just draped my antenna wire across the top of the fence here, and we'll see if that's sufficient for picking up a radio signal. Well, the project was a success. I was able to hear a little bit of radio stations that I could tune by running my wiper back and forth across the coil. A couple of notes. One is, this is an unpowered radio. The only thing that powers this radio are the radio waves themselves trying to get to a ground. And that's why you need this very sensitive earpiece as opposed to what you normally would have on your iPhone or iPod. And even with this very sensitive earpiece, you also have to listen. You're not going to expect this to be blaring in your ear. You'll have to focus on what you're listening to, even to be able to understand the words, I've found often. Now that might vary based upon the quality of your ground, the quality of your antenna, and the strength of the radio stations around you. But if you don't hear anything, plug your other ear and make sure you're listening closely and you don't have a bunch of background noise that might be making it difficult to hear what you're actually hearing. Without an amplifier, this is a very quiet radio. It's a very simple radio, and there's also an advantage that it doesn't need batteries. It'll never run out of batteries, and it'll work even when the power's out. All you need is a ground connection. Another thing is, when I ordered these headphones for the project, I ordered a package of 10, and on my first setup, it didn't work at all, and I was a little bit, confused about what was going on. I thought I followed all the instructions correctly. And what it actually turned out is one of the headphones was defective and wasn't working. When I replaced the headphone with another headphone, it worked just fine. Now, since the original one, I've made 2 more. This is the only one that I've completed assembly on, but the other 2 headphones have worked fine. So I need to run through the other 7 headphones that I have before the DIN meeting to make sure that each of them works, because that would be kind of disappointing for a Cub Scout to do all this assembly work and then, hey, mine's not working, what's wrong? Oh, you have a bad headphone. So I'm very hopeful that I have enough headphones to make this work, enough good headphones to make this work for the entire DIN. So I don't know that I would need to go through all of the assembly on each one and then take it apart, but I am at least going to test all of the headphones prior to the DIN meeting. As a matter of fact, I was talking about how quiet the radio station is. I can't even use my iPhone that I'm using to record this video to record the sound from the headphone, even with the iPhone microphone directly against the headphone here. There's just not enough volume there to be able to pick it up on the microphone. So anyway, the radio works. I'll have links for the source of where I found information on how to build this type of radio, as well as where you can order the various parts. Like I mentioned, the headphone tends to be a specialty order type of piece, as well as the diodes. Now you might have better luck at your electronics store. I was thinking I could just run down to Fry's here in Houston, which is a great retailer, carries a lot of electronic components, and they had a spot on the shelf for these diodes. They were sold out. I don't know if that was just the luck of the draw, or they normally don't carry them, but I did not find any of these earphones. But I'll have information on how to order them. The magnet wire is a little bit easier to find. And the resistors can be found anywhere, including your local Radio Shack, as well as the bare wire pieces and the terminal connectors. So I hope you found this helpful, and yours in scouting fun.